Okay, the second part of section 10.2 talks about arc length. Now, we have talked about finding the arc measure. If I asked you, what is the measure of arc QR? The measure is the same as the central angle. You would tell me this measure is 120. Okay? However, that is a different thing than when we talk about the arc length. So, it sounds similar, it sounds like it might be the same thing, but it means a totally different thing. Here is the difference in arc measure and arc length. The measure corresponds with the angle, the length corresponds with the actual distance around the circle. So if we have a really small circle, our arc length is going to be a lot smaller. The distance from one point to another point is going to be a lot smaller than if we had a big circle and finding the distance from Q to R. Okay, so to kind of think about this a little bit more clear, imagine if we took a string and we laid a string around the edge of this whole circle. Okay, that would be representing an arc length. That arc length is going all the way around. What do we call the arc length that goes all the way around a circle? Almost gave you the answer there. That's your circumference. Okay, so we could say circumference is the length of the arc all the way around. Now, if I took a string and stretched it out all the way around the circle, and then I held my finger where that string ended, or if I cut that string so that it's exactly laying around this edge, how could I measure that actual length? I could get a yardstick over there, and I could straighten out my string, and I could put it against that yardstick, and I could measure how long it actually is. So we are not talking about degrees anymore when we talk about the length here. We're talking about the distance on part of the arc, or the whole arc is circumference. Okay? Now, it'll never ask you for the whole arc length unless it is asking you for circumference specifically. There's a special word for that, circumference. But you may be asked, what's the length of the arc of QR? And it just wants the distance from this Q to this R and stop. So that would be like taking the string and just putting it on this part, and then let's stretch that out and let's measure it and see what the actual distance is. Instead of doing that actual measuring every time, there's a way that we have a strategy for that we can come up with what this actual length is using some different information that we know. Okay? To find the length of arc QR, to find the arc length, compare the part and the whole of the arc measures with the arc lengths. Okay, I'm going to explain this a little bit more using a formula for a proportion. Okay, now think of it like this. We want to set up a proportion. We are going to use the measure of the arc, 120. But we are also going to think about this length thing, but we can do a proportion with this. Anytime you want to find arc length, think about proportions in this way. Let's think about taking a part of something and then the whole thing and making that a ratio. And then we're going to set it equal to a part of something else and then the whole thing of something else. If we can do the same stuff here, like part over whole equals part over whole, this is a proportion setup that we can always use to help us find something like arc length. This also works in probability, and we'll work a little bit with probability later in the semester. Part over whole equals part over whole. You can always compare two things and set up a proportion with anything. Okay, so let's see what our part and our whole is. We're going to take the measures and compare them, and then we're going to do the lengths to the part and to the whole of the circle. Okay, so let's do the lengths first. Let's talk about lengths. On the top of this first proportion, what is the part when we're working with the lengths here. The part that I want to find is QR. Do I know that length yet? Do I know that distance? No. That's the thing we're asked for. Find the length of QR. So that's going to be my variable. For right now, I'm going to write in that word length. I'm going to use L as the variable there. Okay, so down underneath here, I'm going to write a new proportion, just abbreviated. Okay. What is the whole thing in this circle? Okay, if the part of your arc is QR, what represents the whole arc? We just talked about this. What's that word all the way around? That's your circumference. Okay, and then you're going to set it equal to the part and the whole of the measures. Okay, what is the measure of just this part, just this arc? Its measure is 120. Excuse me. I'm going to put that 120 on my bottom one. For right now, let me do this. I'm going to put the measure of the arc. Okay. So whatever this angle measure is for any problem, you're going to put that measure on the top because that's the part of the circle you're focusing on. What is the measure of the whole circle? It's always 360. So this number right here is never going to change for this setup because the whole measure in a circle is always 360 all the way around. So here is your formula or your proportion that we are going to use to set up to find the length. Okay? Anything that you want to find, that is where your variable is left in. That's why we use variables. It's the thing we don't know. So there's your L. For this picture here, this example, do we have enough information that we can actually find the circumference all the way around? If you're not sure, let's go back through the steps and let's think about circumference. What is your formula for circumference? Psi equals pi times di. You guys should just have this down pat. It should be there. You should be able to pop it out. Okay, so make sure you know it. If you don't, you need to study over the weekend and be ready for a formula quiz on Monday. I might just throw one in there. Circumference equals pi times di. Well, what does it give you in this information? It gives you 15. Is that your diameter? No, that's just a radius. So if I know my radius is 15, what does my diameter all the way across have to be? It's got to be 30. Okay, so what is your circumference for this circle? Whatever 30 times pi is, that's going to be your circumference. Grab your calculator. 30 times pi, your decimal for circumference is 94.25 if you round it to 2 decimal places. Okay, so where can that go in my formula here? This is the whole distance around your circle. Okay, part is the thing we don't know. We want just this piece. Don't know it yet. The whole is your circumference all the way around 94.25. Okay, now we are going to take the measure of the arc. What is the part of the arc? We do have that. Your arc measure is 120. And then what did we talk about is the whole always? Always 360. Okay, so now look at your proportion here. If you have everything filled in, can't you easily solve it for the length that you want? So here we go. I'm going to cross multiply. Please do this on your calculator. And then divide by 360. When you solve this for L, you will get 31.41590. It keeps going. If we want to round it off, more decimal places is better than less. Okay, so this time I rounded to 2. Take it to 3. At least 2 decimal places. To do more is going to be better. Okay, so you have lots of decimals on that one. Here is the length of this arc. Okay, so take a look. What did we just find? If we were to take a string and stretch out a string right across this circle right here, and then we would take a ruler and stretch that string out, how long would that arc be? 31.416 on your arc length. Okay. All right, that's the first part of your lesson. We're going to have a few homework problems to try on this tonight, and we have a little bit more to learn today before you get into your full homework assignment.